Good afternoon and welcome to the T2 Tech webinar series. Thanks for joining us. I see a few names popping up here. Welcome. We'll be getting started at 5 after with our featured partner this week, Caringo. Thanks again for joining us, and just sit tight, maybe refill your coffee, and we'll get going in a few minutes here. Thanks again for joining. You're locked to the T2 Tech webinar series on S3 and Cloud Conversations. Should be getting going here in just a couple minutes. Going to wait for a few more people to trickle in before we start our conversation with Caringo. All righty, thanks again for joining the T2 Tech webinar here with Caringo. Going to get started in just a moment. Just want to give another minute or two, see if we have some stragglers come in, and then we will get started. So thanks for your patience, and thank you for joining. All right, thanks everyone for your patience. Without further ado, I'd like to introduce Dominic Tarabacchia from T2 Computing, Manager of Corporate Sales, who will be your host for today. How are you, Dom?
I'm all right. How are you today?
I'm doing okay.
Good, good, good. Hey, thank you so much for the intro. Welcome to T2 Computing's Tuesday's webinar. Today, I am happy to announce that we are featuring Caringo. What they will be talking about is Swarm Object Storage. But before we get into Caringo's presentation, I'd like to give you a quick history on T2 Computing. As you know, T2 Computing is based here in New York City. We were actually born out of the TechServe days. We are a reseller for all of the Caringo products. And what we've been busy with in the past few months now during the pandemic is we were able to work with clients and have them do some remote editing. So their editors are able to work from home. There is actually no minimum cost for this. There's no hardware required as well, and everything is configured remotely, so we don't have to go into your offices. And so far up to date, we have approximately 800 editors. With that in mind, we also have a professional services team. We have about 17 technicians on staff. We can help and build workflow designs. From there, when we build your workflow designs, we will also build the system into your environment. And we can also support the systems that we help design and build for you. With that in mind, what I would like to do is to kick it off to Caringo. And on the call today with Caringo, we have Ben Cantor. He is the Vice President of Sales. And Ryan Meek, he is the Principal Solutions Architect with Caringo. Ben and Ryan, how are you guys doing today?
We're doing great, doing great. Thank you for having us on today. I think I speak for Ryan saying this is a real honor to share our story and our solution with you all, as well as have a great conversation about cloud and where it is today and workflows. So let me share my slides.
Great to be here. Thanks. Thanks, Dominic, and thanks, Daniel.
And let me know. Ooh, I think you guys can see pictures of yourselves. Let me move those out of the way. You all can see the slides, hopefully.
Yes.
Perfect. So again, my name is Ben Cantor, and Ryan's on here with us. As mentioned, VP of Sales, been with Kringle 5 years, come from the industry, been in the IT industry, over 20 years now. Oh, that's scary. And Ryan, you've been with Kringle a long time. Do you want to just give a little of your history?
I have. I actually started with Kringo in 2006 after turning down a job offer on the back of a napkin in 2005. And I guess I joined as an engineer, and then that turned into testing and training, and then working with customers in the field, and helping our customers be successful. So it's been a lot of cloud. It's been a lot of object storage and a lot of data protection.
Awesome, Ryan. So as we get started here, the first thing to point out about Kringle and why, about our history. So we've been around 15 years, coming up on our 16th anniversary, which makes us, for an object storage company, on the older side of things. We've been around a while, and we've produced a lot of code, a lot of software. In fact, we're currently shipping version 11.3 with version 12 in the near future. Little exclusive break for you guys all on the podcast today, or webcast today, with tons of customers. And as an organization, we're focused in 3 main areas. Federal government has always been one of our largest customers, but also high performance computing, so big data sets, supercomputing, research, and the one with the most customers and where we are most embedded is media and entertainment. You see here some logos. We have many more logos beyond this, but it's whether it's on the content delivery side, whether it's on the streaming services side, whether it's a professional sports team, or whether it's more for analytics and a side of the business. We're fully threaded throughout the media and entertainment world, to say the least. And so as we get into this, once my mouse catches up with us, come on, we want to start off with just a primer on what is object storage. We say object storage. So a little known thing, all the public clouds, Google, Azure, Amazon S3, but behind the covers is object storage. That is the storage platform they're using behind the scenes. So when you hear public cloud, it's object storage. If you hear private cloud, it's object storage. And that's what we're going to refer to and be talking about today, is that technology. The other thing I want to point out is a little bit of housekeeping here before we dive into things is you're going to hear the term S3. S3 can mean a couple different things. There's S3, the protocol, which was developed by Amazon, and is now the de facto standard as a protocol for this communication with cloud. But there's also S3, the Amazon storage service. That's the public cloud, that storage that they're offering. So we may say it a couple times. It's very common to hear it used in both contexts. I just want you to know it's a protocol as well as a storage service. So as we get into this, Ryan, how would you define, or how would you describe object storage to someone who's new to object storage?
Well, I would just distinguish it from file and block, in that with object storage, these are relatively new systems that were designed for massive scale. And in particular, it's where the idea of metadata and data is encapsulated. So objects include metadata and their data, and ideally, they're portable across the physical infrastructure. So location of the object isn't as important. What's important is a service can fulfill a request for that object, find the object, and then serve it back to the user. It's also sort of inherently multi-site in that it's location independent. And so, these are services that were designed for billions of objects and petabytes of data. That really distinguishes these systems from, single machine systems, that are more file and block oriented.
So when I joined Kringle over 5 years ago, one of the first things they taught me was about the valet service of a car as an analogy,
Sure.
right? I mean, I know that it's not as tight as it was then, but do you want to share that analogy? I think it's a pretty good one to help people understand.
Yeah, I think the valet analogy for object storage, I mean, as well as the coat check analogy for object storage, was particularly useful early on when objects generally had a universally unique identifier. So the idea was, store an object in the system gives you a unique identifier for that object, and then at any time in the future, if you want that object, just supply the system with the UUID and the system will service the request. I think what's more common now is a user supplied name. So for instance, with Amazon, they give you a bucket. Systems like ours let you choose the bucket name, and then you would actually give a name for the object when you stored it, and then you supply the name when you retrieve it, and then the system responds to it. So I think the coat check analogy was more early on, but all these objects still have universally unique identifiers under the covers, so it's still a good concept to distinguish object storage. It's like, hey, the namespace has room for plenty of things here. It won't get crowded or fall down with a couple billion.
Yeah, to say the least. So as we, look at the world today, or the media and entertainment world, what are people using? Private cloud, public cloud. What are they using these systems for to help solve? What challenges are they trying to deal with?
I mean, generally it's scale, right? So if everything you want to do fits on one machine, you don't really need object storage. But if you have petabytes of data or billions of files, you need a system that can handle hardware failures seamlessly. And you need a system ideally that doesn't take all day to administrate. And if at the same time it gives you sort of geo-wide access to that data without knowing, which server or which disk the actual object is on, that's all really ideal. So that's sort of the sharing aspect there. And, the manual effort needs to be minimized or fully automated.
Yeah, I think you brought up a good point. It's common customers that we deal with. Sometimes it's not the capacity, but it's maybe they're recording thumbnails or they're recording audio files where they have billions upon billions upon billions of small files. And managing that on a traditional file system both was labor intensive, but also the performance took a hit as well. So it's, when we talk capacity, it's not just number of petabytes or exabytes. It's also number of files or objects, as we would say. I would say that comes in handy.
Exactly.
Hey, guys, I have a quick question. How do you guys how is object storage sold?
Oh, that's a great question. So I went ahead too fast there, premature button clicking. Speaking, we can only speak really for ourselves exactly, but there's really, you have appliance model, you have and a software defined model. You have, that's from, the tangible pieces, right? Are you just getting licensing or are you getting hardware and software together? And then you also have the options of either a subscription model, which we'll get into a little more detail later, or a traditional perpetual license model. So depending on what the right solution is, and depending who you're dealing with, you do have tons of options when it comes to private cloud or object storage like we do. Public cloud, Amazon, Microsoft Azure, or the others, it's always a subscription model where it's an ongoing operational cost based typically on capacity and some access fees or different fees associated with how that you want that data managed on the back end by that service provider.
Thank you. Thank you so much.
Absolutely. Let me see, going forward. So Ryan, do you want to take us through one of the most common workflows that we see in the media and entertainment space?
Right, sure. So this is really just to address like, okay, well, where, in an on-prem situation, where does that cluster or object storage or cloud storage fit in the workflow? And the nice thing to just notice here is There's still primary storage. That's still the right place to do things like video editing. And then data movers can actually push those files to the on-premise private cloud, based on time accessed or based on, just whether that project needs to be archived. The other way it's really common now, especially, is with digital asset managers or media asset managers. You can generally point those to an on-prem cloud solution, and they integrate through S3, right? And that's back to the distinguishing note you were making at the beginning, where S3 is the protocol. The asset manager can point at any service that can speak that protocol. We can, other systems generally can. And so it's a transparent, seamless integration. Years ago, to take advantage of object storage and private cloud, people would have to maybe even write software or do custom scripting to move content. Now it's really easy. I mean, the asset management system they are using probably includes an S3 integration to an archive that can just be pointed at the on-prem cluster. And then that cluster can actually serve the content. Either it's video on demand or over-the-top delivery. It's an HTTP on the front-end service, so that can stream directly, or it can be connected to other clusters, say in Europe or Asia. At that point, you can do quite a few things with the content, so it becomes very useful.
That's great. That's great, Ryan. And one thing to note, and we run into, so as Ryan was talking, I'm not sure if you can see the pointer, but the connection between the primary storage and asset manager to the archive, or VOD storage as we call it here, this is using that S3 protocol. Not all object storage or public clouds, private clouds are the same in the treatment of that S3 protocol. Because it's controlled by Amazon, it's their code, if you will, or their protocol they developed. They do make frequent changes to it. And so it's important for the vendors, when you're looking at this, is how they adhere to that S3 protocol. It's not always plug and play. I can speak to us. We do a very good job where, it doesn't matter, your MAM, you take it off the shelf, and within 5 minutes, we're able to be written to from that asset manager and retrieve from that asset manager. But not all are the same. So that's one thing I would say is a takeaway. Make sure you test that S3 integration between the different pieces. Don't just assume it's going to work.
I will say, lately they work out of the box most of the time, but it's always good. It's always a good step to check. But it's really settled down compared to the Wild West in the early days.
That's for sure. That's for sure. And take us through, this is another one where you're involving an on-prem and a cloud, sort of public cloud and private cloud, shaking hands, playing nice in the sandbox. Do you want to talk about this use case?
Yeah, I mean, I would say with an on-prem cluster or a cluster at a certain location, one of the questions these days, and really since people started paying the more attention to it, was probably Katrina was probably the big inflection point, but at least in the United States. Where is the DR copy, or where's the DR, the disaster recovery for all this content if you lose your primary site? And in our case, we can push the content to a public cloud if that's running, with S3, if it's Wasabi, if it's Amazon. So that's nice, especially with the new abnormal with COVID. If you've been meaning to get around to adding a DR copy, it's really nice to be able to check that off the list without having to go to a data center. So, and once the content is there, you can use it in a variety of ways. Once it's up, even in the private cloud location, you can take advantage of that by doing, server-side restores or video clippings. And, it's really available for your workflow, wherever your users are, from tablets or home offices. HTTP is the most portable protocol in the world. So it's really nice to have HTTP and sort of be cloud prepared and COVID prepared in that way.
So I want to pull something out here. Did I catch you say the new abnormal
I said the new abnormal because the new normal just bugs me. I don't even want to think that way.
You should definitely trademark that. So if anyone's listening and uses it, please pay due to Ryan on that. Make sure you drop his name.
Hey, Ben and Ryan, we got a question that came in.
Sure.
How does on-premise pricing compare to S3 pricing?
Well, that's a good question. One that comes up because people think automatically going to the public cloud is going to be less expensive. And that's false. So typically what we see in the marketplace on average for an Amazon S3 instance, you're paying about $20 to $25 a terabyte per month. And that's without the egress fees and things like that. So it gets pretty costly pretty quickly to store things there. Comparatively, a on-premise solution like we offer, combining hardware and software, you're more in the $12 to $15 per terabyte per month type range. Now, again, there is different options on subscription versus perpetual and appliance that. So there are some variables in those numbers for the ranges, but typically an on-prem solution from a expenditure is going to cost less. Now there is differences, and we're going to go over those, coming up in terms of FTEs and things like that you do have to consider. But all in all, those numbers are pretty accurate. 12 to 15 for on-prem private cloud, an object store like us, whereas it's 23 to, depends on how many, but let's say around $25 for Amazon, including support S3. Which a lot of people are surprised by that pricing difference, to say the least.
Yep, understood. Thank you.
Absolutely. So Ryan, we're throwing up here, and that was a perfect segue to this. So we talked about the financial differences a little bit, but what are some of the high-level differences that people need to consider when they're looking at a public cloud deployment versus a private cloud deployment?
The big ones right away is performance. Public clouds will be high latency, low bandwidth, low throughput compared to local networks. So if what you're operating on or working on or what your systems in either the data center or the office need access to needs to be fast, the local resources will be faster. The private cloud providers will be, administrating more hardware, but to your point a few moments ago, that might actually be more cost effective and a much lower cost over time. And then I would point out another thing that we probably haven't brought this up yet, but with a private cloud, you will probably get more protocols available to access the content in the cloud. So for instance, if you're talking to Amazon's S3, that's HTTP. If you're talking to something like Swarm, that can be something like NFS to access the same namespace, or it can be something like SMB to access the same namespace. And so it's a little more normal in the enterprise private cloud on-prem space to have multi-protocol access to the same content, the same cluster, the same namespace. So if that flexibility is important to you, that will steer you towards more of a private hybrid cloud.
Yeah, and I do want to call out, you mentioned about how much administrative work or, the differences there. So with our solution, I can only speak to, we have, one customer, I think of themselves, it's a part-time administrator, part-time, but he's managing 6 different clusters and they total over 60 petabytes. And he's doing this in a part-time work because he's also responsible for some applications and some other things as well. It's not a dedicated full-time person to manage an object store. They are
if you're doing it right, you only need part-time administrators, even into double-digit petabytes and multiple clusters. Disk recoveries are automatic. Maintenance can be done with 0 downtime upgrades. So that kind of scaling is really important. You don't want to have to be a Linux administrator for another 200 servers.
Yeah,
you just don't. And I actually, on a recent conversation, we were talking to someone that would have had to, they would have had to have been the primary administrator on, a particular system that can do object storage, that has a file system underneath, and you have to be the Linux administrator on all the servers. And, he understood right away, he wanted the software appliance model. And it really mattered to him because he had other things on his to-do list rather than take care of those servers.
Well, it's funny. I think it's something that's always stuck in my mind. Early on when I was started in technology sales, one of the people presented this way: technology should enable you to do more from your desk, right? If you think about it, because if you can do more from your desk, you can get more done in a day, more efficient. So it's something that always stuck with me. If you're having to manage, that many systems, 200 Linux systems, there's not much else you're going to have time for, to say the least.
Yeah, I mean, we had early on, our CTO used to say something that didn't always endear us to storage administrators. He would say, storage administration is too boring for humans. And although it didn't endear us to a lot of them, I think the value add was well taken by a lot of people too that didn't necessarily want that to be their entire job. But
and before we advance to the next slide, I do want to point out, when we mentioned protocol, with a solution like ours, it's a single namespace between NFS, the S3 protocol we mentioned, HTTP, and some APIs. So it's all one namespace. A lot of times for public cloud, it may not be a single namespace. If you want an NFS service, that has to be a different instance or sometimes a different provider to get that service. And it's not going to be in the same namespace as maybe your S3 type subscription is. So it's something to think about as well. If you do have that mixed protocol requirements, that hybrid environment that we showed you earlier, where Object Store on-prem is the first stop with that single namespace, and then that's the replication is a way to overcome that as well. So to dig a little deeper into the differences, we talk to customers all the time about what's important to them when they look at these type solutions. Brian, do you want to dig in a little deeper into a couple of these areas?
Yeah, so I mean, we've talked a lot about performance. I think having a place for your users to log into to actually do content management is a really big deal. That's something that we excel at. For instance, it used to be the case that people would have to write code to take advantage of the object store, and in some cases, the public clouds are still in that situation. Whereas we have, a fully featured content user interface, and customers can download content, they can share content. They even have access to the metadata. We talked a little bit about metadata, but there's a rich metadata system in the on-premise object store that lets you search through hundreds of millions or billions of objects and get millisecond response times. And your users can actually do metadata tagging through the user interfaces. So it's almost like, the expectations of the enterprise look and feel, you can expect that in the on-prem systems a little more than you can expect it in the public clouds. And then I think really getting down into the weeds, you can select your data protection strategies, in the private cloud case. We have some use cases that are the digital archives for a country, digital media archives for a country. And they've chosen strategies with, 5-disk protection, 5-disk failure protection for, 15 nines of data durability, in a certain domain for certain classes of content. You don't get to make those choices for yourself when you use a public cloud. And so, having that flexibility is a big deal. If it's your CD collection and you're a home user, that's not such a big deal. But if you're a digital library and these are performances of musicians, and this is the authoritative copy in the world, you might want to control that durability, and you will have more control over that with the on-premise, model. So those are, you just have more control. It's more control per object and more control for the data set.
Right. It's, I think we've talked to people before, not all data is created equal, right?
Right.
So you want to assign more fiscal assets, if you will, to the important data and less fiscal assets to the less important data. So with on-prem, you can really craft an architecture solution to support that.
Exactly.
So you mentioned the, instant, this is a snapshot of our portal, but do you want to talk to this a little bit more about that instant access?
Yeah, I mean, I think you can kind of see it. The shot that's on top, you can actually see a little bit into the metadata structure. Like I said, it is HTTP, so the metadata is, name, value, text pairs. Those are actually persisted with the object, so they come right up when you access an object. You can add metadata tagging, you can use custom metadata, and then they're actually indexed for high performance querying. So you can say, show me all the objects that not only are MP4s, but they're tagged with the NAB tag from our campaign last year, NAB 2019. By the way, I miss NAB so much. Yeah, and so, you can also look at the content here. You can search into the middle of a video. It's streaming directly off the storage, so, you don't have to download the content. I mean, net, it's just very responsive, very good looking web portal, integrated with search, and, you can even generate server-side clips if you want to share those. It's really nice to have. I mean, it makes all the difference.
And one thing I want to call out, you mentioned metadata. Metadata, the importance of it is growing every year. And as more AI or ML applications become available downstream, whether it be, like something like a Veritone or others, facial recognition, all these different AI engines that are now available, the metadata and the tagging becomes more and more valuable. The richness that's provided to you from an on-prem object store or private cloud, it's so much more capable. So if that's something in your roadmap to really get into that AI or ML, you really should look at the differences on metadata handling between these different systems, to say the least. When you agree,
Well,
Ryan?
and especially in those cases, it matters to be, with local land speeds reading objects. So, if you have 200 different servers crunching a data set, you don't want that to be coming down from a public cloud. You want that to be local access, especially for in a situation where you might have ingress and egress fees as well.
So another common point that we get into pretty deep discussion that comes up is you mentioned erasure coding and data protection, but this modern approach is different than RAID. Do you want to talk, or can you share how it's different and how it's more reliable?
Right, and so this is sort of the data protection behind what I was just briefly introducing with different erasure coding strategies that are possible for protecting content against multiple drive failures. So the basic approach is just make multiple replicas. So if you have an object, put that object on multiple servers, on multiple disks, and you're good. Now, if those objects are very small, that's super efficient. If those objects are very large and you have a petabyte of logical data, you don't necessarily want 5 or 6 petabytes. So you want to use something like erasure coding. And that's, you can think of it as object level RAID. So you can dial in your strategy. So you have something like, 5 data segments and 3 parity segments. And that will tolerate a triple disk failure in your system, 3 disk failures. And you can reconstitute the object with any 5 segments. So, and that's highly flexible. So if you wanted to save capacity and tolerate even more disk failures, you could do something like 10 data segments and 4 parity segments. So you would tolerate 4 drive failures simultaneously. Just excellent, flexible data protection. And, it makes it an excellent backend for S3 and cloud, really.
Right. And it's important to note, so we're speaking from the Kringle perspective where we do have that flexibility, where you can choose your erasure coding scheme, take advantage of different hardware you have. Not all systems do that, right? Some are pretty limited, or preset to a couple choices that you have. That does impact whether it's the right fit for you or not. So it's something to keep in mind as you get into erasure coding, see how it relates to the hardware itself and if it gives you that flexibility. That's an important note. So this is pretty much our last slide, and I wouldn't be doing my job as a sales guy if I didn't put a plug in for our solution, Kringle Swarm. what really separates at high level is there's three things that we do different. And the biggest one is that architecture. Without getting too deep, we have a different architecture that handles metadata differently than other solutions, a lot better throughput because of our parallel processing, and it's a true it's a software appliance. We've decoupled the hardware from the application. The other thing in the web portal, you saw our snapshot of just one, but it's so much more powerful. It's a framework of multi-tenancy for you. It's really, really slick and built in. And the last part is the administration. I gave the reference of one of our customers with the 6 clusters, 60 petabytes plus minutes a day that they manage it. I mean, when someone says we want to go test a POC, for us, we say, okay, block out a couple hours and we'll get you up and running to test a full production level deployment of our servers, or our software, I should say. So that's the plug for Kringle. Obviously, reach out to us. We'd be happy to have any conversation about our solution, about the public versus private cloud, or just in general. We love to have those conversations, not in a sales capacity, just as professionals discussing those different things. And then the last slide here is just to show you object stores are really integrated to the ecosystem. This is just a snapshot of some of the logos. If I were to update this with some of the other ones that we've been certified with, I would need 4 slides. So I just did some snapshots there. I think we have a question from there. I do want to bring out, can Swarm be deployed on any hardware? The answer is we utilize any x86 servers. So the answer is pretty much yes. You can mix and match hardware, right, Ryan? I mean,
I would say yes. x86 standard servers, if it can run Linux, we run on it. That is most servers. I mean, I guess ARM servers we would not run on, but I almost don't know of any in production right now. So, and we've actually had conversations over the years about porting to ARM. So
Yeah.
stand by.
It's not uncommon for us to deploy on what sometimes people refer
Don't tell our engineers I brought that up. It's officially not on the roadmap.
It is now. One of the things, it's common for customers to use existing hardware with us and put together what we call a Franken cluster, where they have a couple Odells, a couple HPEs, and a Cisco server that they're leveraging those all together in one cluster with us running on top to start off with. And then as their budget or buying cycles allow, they replace those old servers with new servers and get a boost in performance, capabilities, capacity. So there's really a lot of capabilities there as well.
That's a really good point. So we probably didn't spend enough time on that actually. So once you have a large cluster and you want to extend it, you don't want to have to go back and buy last year's servers or the year before. You just want to buy the best servers you can get at the price point that you want. So, you want systems that enable that kind of thing, which is luckily exactly what we do.
Hey, Ryan, for object storage, what kind of real world performance are they getting?
It really just depends on the hardware so we generally measure performance in overall throughput and in operations per second for small files. So, we've tested north of 20 to 30 gigabytes per second over S3 in some medium-sized clusters. And we actually do that and publish that from customer clusters, not a cooked up analyst situation. So,
Awesome.
those are through high throughput clusters, but we generally measure throughput plus ops per second for very small files. That's a good question though.
And my last question, which NAB are you missing? The one in New York or the one in Vegas?
I miss all of them.
Well, let's say the poker tables miss him more in Vegas than necessarily the underground.
Some days that's true for sure.
That's awesome. That's awesome. I think that's all the questions. Unless you want, maybe we'll wait another few seconds to see if anything else pops up. But while we're waiting, Ben, thank you very much for joining us with us today. And Ryan, thank you so much for joining as well. I think it was a great session that we had today. Thank God we are taping this, so this way we have it for future use and reference, and we can always go back, and our clients can go back and, if they have any questions or they want to look at Caringo, they can go in and take a look at it. So this was great. I'm going to pass it over back to Dan. Dan, are you there?
I'm here. Sure am. That was awesome,
Awesome.
guys.
Thank
Appreciate
you
the
so much.
amazing content there. And thanks everyone who joined. Feel free to reach out to the T2 team with any questions, Coringo or otherwise. We'll be back next week with Igneous. And what was nice there at the end on your last little ecosystem page is a number of partners that we work with featured there, and also in upcoming weeks joining us in similar conversations. So glad to see we're all on the same team here as we push forward to 2021, hopefully leaving 2020 behind us.
Yeah.
Fantastic.
Thanks very much, guys.
And go Yankees.
Let's
I don't know about that. I think you might have lost Ben there.
I was going to say, when you said it all on the same team, as long as it's not the Jets or the Giants.
Thank you, guys.
All right, guys. Take care,
Have a great
everyone.
day.
Take
Bye.
care.
Bye-bye.
Bye-bye.
Bye-bye.